Okay, we will be seeing Ohm's law now. So, when we talk about Ohm's law, if you consider a conductor, and let's say current flows through this conductor. First of all, you have to understand only in a closed circuit current can flow. So I am just taking a part of the wire, a part of the conductor that is connected to a circuit, entire circuit. So current flows through this particular conductor. So according to Ohm's law, and if you consider or if you take a voltmeter and keep it over here, it will be having a certain voltage. Voltage you are finding it between two nodes. You have to take between these two ends of the conductor. And current flows through the conductor. Again, current is nothing but rate of flow of charges, rate of flow of electrons. According to Ohm's law, if you keep the temperature constant, now let's say it's 25 degrees centigrade. Okay, so the constant temperature should be 25 degrees centigrade throughout the experiment. So if you keep the temperature constant, then the current flowing through the conductor is directly proportional to the voltage at the two ends of the conductor. Let me repeat Ohm's law. According to Ohm's law, when you keep the temperature constant, that time the current flowing through the conductor is equal to the potential around the potential at the ends of the conductor. That is I proportional to V. I proportional to V, or I is equal to V by R, or V is equal to I into R. This is what. This is your answer. Again, understand the sentence. The important thing is temperature should be constant. If there is variation in temperature, obviously this law doesn't hold good. Okay? While keeping temperature constant, the current flowing through the conductor is directly proportional to the potential at the two ends of the conductor. That's what we have. This is Ohm's law. Okay? Ohm's law. It will be useful while you solve for parallel circuit or series circuit. Everything will be same. Resistors in parallel, resistors in series, it will be that. Okay. Now, next part actually what we see over here is that few things before we go to parallel connection and series connection. Let's see. That is power. Okay. Power when we see. Okay. Now, general meaning of power in the sense, if some work can be done, okay, or if you say, let's say there is 1 ton of weight, and you are exactly keeping that on, or you are keeping that on let's say a bullock cart or a horse cart you are keeping, and you make the bullocks or the horses to move from one place to another, from here to let's say 2 kilometers. It will take some amount of time. It will take some, let's say it will take half an hour. Next, if you talk about a truck, and again you keep 1 ton of weight in that huge truck, and again it has to move from one place to another, let's say 1 or 2 kilometers, same exact distance what was before, it might take just some 5 or 10 minutes, or even lesser than that. That will take. So you can see that the truck has more power than the animals or whatever other means we had taken. So here when we talk about power, that is exactly mechanical power I was talking about. But here exactly when we talk about, it is the rate at which work is done. Power is given by P. It is the rate at which work is done. So P is equal to V into I. Rate at which work is done. V into I. Okay. You can even take small capital letter I also. There is no actually hardcore rule with this actually. You can take capital letter I. That's no problem with this. So you have to see that the rate at which work is done. The rate at which work is done. So here we have electrical power, voltage into current. Voltage into current. So you are seeing how much potential is there and what is the flow of current. That is called as power. Now, if a person, if you talk about mechanical, I am generally taking the general examples so that you can understand. When we talk about mechanical power, a person might be strong, very exactly strong. But if he is not able to lift a certain amount of weight, then you don't consider that person as a powerful person. So, not just now voltage is nothing but electric potential. A person's strength exactly when we see that is his potential and the work exactly that is done, that can be compared to our current. Current is flow of electrons. First of all, how much potential is there and the rate of flow of electrons. How much potential and the rate of flow. If a weightlifter is considered, how much strong he is or she is and how much weight that particular person can lift. Because just strength is not enough. Or just lifting weights without any strength, that is also not enough. Both should be done. So potential and current, that will give power. So P can be written as V into I, or P can also be written V. From Ohm's law, you get I into R. Again into I, which is nothing but I square R. This is one formula for power. You have this one particular formula for power. Another. Again, when I take this, P is equal to V into I can be written as V by R. So P is equal to V square by R. Another formula. Power has in electrical electrical language, we have exactly study electrical engineering. Power has three formulas: V into I, V square by R, and I square into R. See that, okay? And the unit is watts. Unit is watts. I will take W. Again, this is actually true power. We'll be seeing active power, reactive power later. But starting will be considered true power for watts. Next, let's talk about energy. Energy given by E into E. So E is equal to, now energy is capacity to do work. How much energy do you have exactly? How much energy do you have? How much capacity to do work? Again, how much energy? So V into I into T. V into I into T. It's like if you consider one particular person. Now, if I tell that both, or if I consider two people, and if I tell each of them to run some 200 meters, I think they can exactly run 200 meters. They'll run. Again, I'll tell them again run another 200 meters. So you can see that one of the person who is not that fit enough will lose his pace. And when I tell that same people to both of them to do another 200 meters, then one person might not. Another person who is physically fit can do that work. So we can see that the person who is physically fit has more energy than this particular person. You can take any particular fit. I am just taking general examples. You can talk about any sports like football or cricket. Some people can ball bat for a larger amount of time. If you talk about football, some people can run for a large amount of time. Some people cannot. So generally, the person who can do large amount of work, that we will be saying that person has more energy. If you consider about dams also, dams, higher the more is the height of the dam, higher is the potential energy. Okay, and when we leave exactly the kinetic, the more is the flow of the water, more is the kinetic energy. That actually. Similarly, you are seeing how much power is there for how much amount of time. Power in it's actually nothing but power into time. When we talk about this, when we talk about energy, it is nothing but, and instead of E we are taking actually W. Okay, W. My energy will be in W. So energy is equal to how much power is there for how much amount of time. Okay, how much amount of time? As I told you this particular example, running the example, if I tell almost any person to run 200 meters, any person can run. But how much amount of time can you run 200 meters? Total 200 meters. Total how many times can you do the same work again and again? That will give you your energy level. Okay. So how much power you have, for how much amount of time do you have that? For how much amount of time do you have that much power? Okay, that will be given by energy, which can also be written as V square R into T, or W is equal to I square R into all these formulas will be there. And the formula will be joules. The formula will be joules or joules. You can pronounce any particular manner. This is actually what we have. This is what we have. Power and energy. Again, let me tell you. Power is the rate at which work is done. Okay? So actually it is the rate at which work is done. Now, you should understand that for a person to have power, he should have some amount of potential and he should do some amount of work. So, potential into work. Current understand is flow of electrons, rate of flow of electrons. How much amount of electrons, or what is the rate of flow of electrons with the multiplied into the potential? Multiplied into the potential. That will give power. And when we use Ohm's law, we'll be getting P equal I square into R and P equal V square by R. Next, what we see? Energy. Energy is the capacity to do work. For how much amount of time can you use that same power? The power into time is called energy. Power into time is called energy. W is equal to V square by R. Again, we are using Ohm's law. W is equal to I square into R into T. V square by R into T. The unit is joules. Here, the unit is watts. Okay.